As we move into adding integers, think of adding integers like combining integers. Again, the addition symbol is the plus sign. So when I see a -7 plus a -2, we can also think of this as -7 combined with a -2. And remember, once you get into integers, it's a good idea to use money labels to help you think it out. So remember, negative numbers was money that you owe, and positive numbers was money that you have. So a -7 means $7 that owe combined with $2 that owe. Therefore, the result of that should be then, let's see if we can get this to work here. So it's going to equal then $9 that owe. So if I look at this next example, 8 plus 4, using labels, you have $8 and you have another $4. Therefore, you have a total of $12. As far as rules go, there is a shortcut rule. The rule says basically if you have the signs are the same, just add and keep the same sign. Keep the sign the same. So if I look at this example here, notice that you have a negative number plus a negative number. The signs are the same. Again, a debt plus a debt should represent a bigger debt. So it makes sense to just add those together and keep the sign. So over here, I'm going to have a 264. I'm going to add to that 158. So when I add over here, I ignore the sign. I'm just adding the numbers together. And then 4 plus 8 would be 12. I carry my 1. So 6 plus 5 is 11, plus the 1 makes 12. Carry the 1. So 2 plus 1 is 3, plus 1 more is 4. So the answer should be like 422. So I come over here, I get 422, but I got to remember to keep the sign. So it ends up being a negative 422. So next example I have is, notice the signs are different. So this is a little bit different problem. So I use labels, that's $9 that owe, and you have $2 of income. So notice that income and debt work against each other. So the $2 can help pay off $2 of debt. So that means I'm going to remove $2 of debt, which is going to leave me with $7 of debt. That would be my math reasoning behind that. So -7 would be the answer there. 12 plus -4, here I have $12 of income, and you're combining it with $4 of debt. Notice how, again, those are working against each other. So the $4 of debt is actually going to remove $4 of income, which is going to leave me with $8 of income if I'm using math reasoning behind it. This next example, if we want, we can jump to the rule. The shortcut basically says if the signs are different, you subtract the two numbers and keep the sign of the larger label. So notice how I have more debt. So the answer in the end is going to stay negative. So I owe $98, but I have $52. So what's going to happen is the $52 is going to take away $98 of debt. So I have to figure that out, subtracting. So 98 take away the 52. And so I have 8 take away 2 would be what, 6 there, and then 9 minus 5 would be 4. So I have 46. So I have a 46 there, and I have to remember that my result is I still owe 46, so that would be a negative 46 in the end. And that's how we would be adding integers. As we continue on, let's talk about subtraction of integers, or take away integers. So if I look at the subtraction problem, 9 minus 1, 9 minus 1 means 9 take away 1. So note that the second number is always what's being taken away. So when I look at this problem, 9 take away 1, that's equivalent to 9 plus a negative 1. Because you know that 9 minus 1 is 8, and 9 plus negative 1, if we switch to our integer thinking of money, $9 that I have plus $1 that I owe, well, that dollar of debt's going to remove $1 of income, and I would end up with 8. So either way you do the problem, you get the same answer. So 9 minus 1 is the same thing as 9 plus negative 1. Also, similarly, 10 minus 3, of course, 10 minus 3 would be 7, but also note that 10 plus a negative 3, those are going to be equivalent because a -3 is going to remove $3 of income, and I'm still going to end up with 7. So what this brings us to is a very, very important math ideal, and that is subtraction is equivalent to adding the opposite of the number being taken away. So this is also known as the KCC method, keep, change, change method. So if I see 96 take away 10, this is also equivalent to 96, and I want to add the opposite of 10. So I change subtraction to addition, and the opposite of 10 means a -10, so I change the 10 to a -10. And so those are now equivalent. Either way you look at it, you're still going to be removing $10 from 96, and you'll still end up with a positive 86. So keep, change, chain. You keep the 96. You will change the subtraction to addition symbol. As long as you change the number that you're taking away, the second number, you have to change it to its opposite. So the opposite of a 10 is a -10, and that creates an equivalent addition statement. So when I have 83 take away a -5, that's equivalent to, I can keep the 83. I can change subtraction to adding because that's what we want to do is we want to make an addition problem. But when I do that, I got to use the opposite of the second number. In other words, I got to change the -5 to a +5. So those are equivalent. In this situation, the addition problem is much more clear of what you have to do. You have an income and an income, which is going to give you then a grand total of 88. $10 minus 15 is equivalent to keep the 10, change the subtraction to addition, and change the 15 to a -15. So that's all I got to do is just rewrite it, and those are now equivalent. And notice how these are working against each other. So the 10 is going to remove $10 of debt, but that's still going to leave me with $5 of debt. So since the signs are different, you should be subtracting, 15 take away 10, and 15 take away 10 is going to give me a 5. But I got to remember that which label was bigger? There was more debt involved, so it's got to stay on the debt side. So -5 is the final answer. So if I have -35 take away a -45, again, subtraction can be rewritten as an equivalent addition problem. So we want to keep the -35 as long as we change subtraction to addition and we change the -45 to a +45. So the -35 is going to remove $45 of income. Let me say it again. A -35 is going to remove $35 of income, which is going to leave me $10 of income. Also, notice since the signs are different, you could be working a subtraction problem. So 45 take away 35, and that's going to give you 10. You remember, you have to assign the label of the bigger one, and since it's more positive, the answer's got to remain positive in that example. So that highlights a little bit about subtraction of integers or takeaway of integers. We actually change subtraction problems into addition problems to make the math easier sometimes.